In the last video, our container printed one line and instantly died. Today, we build a container that stays alive, a real web server you can open in your browser. And by the end, you will understand exactly how a request travels from your browser through a port and into a container. That one idea is the fundamental of all Docker networking. Welcome back to the kingdom, Devops AI Kingdom back. This is the image number 2 of our 100 Docker images. 0 to Architect series. Last time we built Hello Kingdom, a container that ran once and exited. Today we built a static site, a container that runs on nginx, a real production web server serving a web page that lives in your browser at localhost. And we meet four brand new ideas of Docker: long running containers, port mapping, detached mode, and naming. Here's the goal for today. We are going to take a simple HTML page that we write, put it inside a container running nginx, which is one of the most used web server on the entire internet. Build that into an image and then run it on, then run it so that when you open your browser to localhost, our page loads. A real web server in a container in about 10 minutes. Let me make the folder for image 2. If you remember in our previous video, we have created a folder called images. So if you see, images folder is there. And now we are creating a second image. For that, we are creating another folder inside images. So we are creating a folder name called 002 static site under images. So using the same command, make directory -p images /002 static site. Now let's cd into that images. Let's cd into images, then we'll see. You can see there are two folders. One is from the previous video, Hello Kingdom, and this is for static image, static site image, which is the second folder. Now let's get inside it. If you see, nothing is there in our image. So first thing, let's talk about nginx. The thing nginx will serve is a single HTML file. By a strong conviction, a web server's default page is called index.html. When you visit a site and don't name a file, the server hands you index.html page only. So let us write a one like a simple index.html page. For that, let's go to vi editor, uh, creating a file index.html, and I will add this content in. You will get this file from our GitHub page. Uh, and let's save the file. So what this index.html will show is, it will show a line, it will showing a static page which will say welcome to the kingdom, and it sets 002 static site. So let's save it. For saving, wq. Okay, let's check the content of index.html again by cat. So we are able to see our file is created successfully. Let's clear it. Now the recipe, that is our Docker file. Docker file with the same grammar as the last time, which is like an instructions in capital, and then it's argument followed by argument. So for opening a Docker file, we use vi command Dockerfile. Okay, so this is the eh, like empty file right now. Press I for insert mode in vi, and then we are just adding two lines here. That is like from nginx and copy. So let me explain these two lines one by one. Line 1 from nginx 1.27 Alpine. Last time we started from plain Alpine and we had nothing but a bare Linux. This time we started from the official nginx image, which is itself built on Alpine, and that's the dash Alpine part, like nginx 1.27 dash Alpine, and it's already contain a fully installed configured nginx web server. This is a huge architect lesson. You almost never start from scratch. You stand on top of an official base image that already did the hard work for you, and you just add your recipe or piece on top of it. And notice I pinned the version again, that is 1.27. Never use latest. Line 2 here, that is the copy command. We are doing copy index.html into user share nginx html index.html path. Here's the key question comes: why that exact long path we are using? Because that is the folder nginx looks in for files to serve by default. It's called the web root. So by copying our page into nginx web root, we are replacing nginx default welcome page into our own page. We didn't configure anything. We just put our file where nginx already expect it to find it, working with the base image instead of fighting it. And notice what is not here from the previous video. There is no CMD line. Why? Because the official nginx image already has its own CMD that it starts the nginx server and keeps it running in the foreground. We inherited it from the from line, like that. This line nginx alpine 2 points like 1.27 already inherited cmd in exactly why this container is going to stay alive instead of exiting like hello kingdom did in our previous video. Now let's save this again, wq, and cat the content of this file. Yeah, so file has been created successfully. I am just using all the command. I am just explaining all the commands so that it will be easy to understand. Now let's move forward with one. Now our Docker file is completed. We have to build a image out of it. So same as before, we are using Docker build command uh, dash hyphen t, and then we'll giving a name static site and tag is 01. Okay, and the build context. So same as from previous video, like this is the Docker build command for building an image. Hyphen T is for giving a name, and it's a tag for it's a flag for giving a name to our image and also the version. And dot is the build context, that is use this folder, whatever files are there in the folder, use it directly. uh, okay, enter it. So you can see like it will pull the nginx base layers. These are shared, and so even in future nginx images we can build and reuse them directly. Okay, now if we see if this image has been successfully created or not for that Docker images. If you see a static site 0.01 size is 49.7 MB has been created. Okay, now image is there. Now this is where everything new happens for us. Whatever command I am writing now, read it carefully because there are three new flags we are going to use, and each one matters a lot. So let me write a command. Let me clear the screen first. Then Docker run for running a container, hyphen d, hyphen name, hyphen p, 8080, port 80, image name is static, site 0.1. So let me break down every single piece in this command first, and then we'll hit enter. Here dash D. This stands like Docker run dash D. Dash D stands for detached. In last video, when we run the container, it took over our terminal actually. And dash D says run this container in the background and give me my terminal back immediately. It prints a long container ID and returns. The container is now running quietly in the background. This is how every real server runs that is in detached mode. And the second flag is hyphen name. Oh, sorry, dash dash name. So last time Docker gave our container a random name like nostalgic turning or blah blah blah. This time we name it ourselves. We just put a name, any random name. Let's say, let me put the name. I forgot to put the name here. Web. Okay. So dash dash name web. So now, so we put a name ourselves this time, which is web. Now we can refer to it by a name. We choose instead of random one or long IDs. Okay, and name must be unique. We have to remember it. You can't have two containers, both name web at the same time. There should be some extra things like web 0102. We can do like that, but not the same name exactly. And then now the most important part, that is hyphen p, followed by 8080 colon 80. So this is the port mapping in Docker, and it is the heart of today's lesson. Let me give it its own section, because if you understand this, you understand Docker networking very well. Think of a container as a house with its own private set of doors, numbered like ports. Inside the container, nginx is listening at a door number 80. That's the standard door for web traffic. But here's the problem: the container's doors are private. Your browsers out on your real machine, and the host cannot reach the container's door 80 directly. They are separated, isolated. Remember from the last video, the network namespace gives the container its own private network. So we need to connect a door on our real local laptop or real machine or server to a door on the container. That is exactly what dash p does. The format is host port colon container port. So 8080 colon 80 reads as a take port 8080 on my real machine or server or my local machine, and forward everything that arrives there into the port 80 inside the container. So when your browser visits localhost colon 8080, it knocks on door 8080 on my on your MacBook or Windows system or anything, any server. Docker forwards that knock through to the door 80 inside the container. Nginx answers and the page comes back. Left number, so this left number 8080, uh, 1 second, yeah. So this left number 8080 is the door on our machine, and right number 80 is inside the container. Uh, host, so like architect note for later under the hood, like DHP creates a firewall rule actually, specifically an IP tables DNAT rule that rewrites the destination of the packet from your host to the container's IP and port. We will open that all the way up in networking deep dive after when we create 58th image. But for today, just hold the doors picture right now. Now let's run it. Okay, so it is saying the container name web is already present. So we have to change the name for now. Let's give it 01, enter. Okay. Also, port 8080 has been taken by like previous process. I will clear that later, but let's put it 8081. Okay. Again, port 80. Let's point to 81. Okay. Okay. So we have changed the name to Web 2 because Web 01 and Web is already taken, and we also update the port number from 8080 to 8082 on our local system, and container port is 82. Okay. So uh, so let's see if any container is running for that Docker PS. You can see we just run a new container with port 8082 uh, on our local system to port 82 inside the container, and there is already one with name web has been running. I think 3 hours ago I have created this, that is for running on port 8080 colon 80. So also last time when we run, let's see, Docker PS. So last time this Docker PS was empty. If you followed my previous video for the first image, because Hello Kingdom has already exited, and this time there it is. So our container named web or web1 is status up with a port colon showing 8080 to 80 or 8082 to 82. It is alive, and it is staying alive because nginx runs in the foreground inside it, never exit on its own. That is what a long running container looks like. Now let's test it. So we are going on a browser. So we are on a browser right now, and we will run localhost port 8080 because this is where our nginx will talk to inside the container when you run it. So you will see welcome to the kingdom image 02. Uh, yeah, so there's a page that is like welcome to the kingdom. It is being served by nginx, and from inside a Docker container through the port we mapped. You just ran a real web server in the container. Now, a long running container needs to be managed, and these are commands you will see in every single day. Like we have to check the logs for this one. So, for that, we have command docker logs and container name, that is web. So, you can see well, the container when it is started, all the logs it has been creating here. If you refresh your browser localhost 8080 and run the logs, you will see a new lines come up because we refresh it, so new connection will be there. Okay, so you can check there are only like 6 7 lines last time. Now it's about 10 lines here. So this is how you check the logs. Now, also, we want to stop our container. So for stopping our container, we have command called docker stop web. Uh, that is container name. Okay, and we also created docker stop web 2. Okay, okay, docker ps web 02. Sorry, so docker stop web 02. It will stop it. Now when you run docker ps, you will see nothing because it stopped the container. Okay, So let's say, like, remember the PID one and SIG term from the last video. Docker is stop sends that polite SIG term signal to nginx, and the PID one inside the container, and nginx shut downs cleanly. Uh, and when we run Docker PS now, it's gone from running list, but it's not deleted yet. It's just stopped. So if it's not deleted, then Docker PS-A will show a container in exited state like 42 seconds or 1 minute ago with zero. Okay, so um, to start again, we have a command docker start and the web server name. Okay, so now you run docker ps again. You will see container is running on port 8080 to 80. But what if we want to permanently delete this container? It will not be in exited state, it will permanently removed. So for that we have command docker rm hyphen a. Rm is for remove, hyphen s for forcefully, name of the container. So if you do docker ps, nothing is there. If you do docker ps hyphen a, so you will see we just deleted the web container. So web 1 and web 2 is there, but there is no web. So we can remove this web 1, web 2 also. Let's see docker rm hyphen f web 01 and web 02. It should work. Okay, so web 1 and web 2 has been removed and deleted. So let's see docker ps again. Nothing is there. Docker ps hyphen a. Nothing is there. Okay. So hyphen f is for forcefully. Now again, like in previous video, we have checked lazy docker for logging purpose and all, right? Where we see picture and at one place. So let's run our image again, like create a container again. Docker run hyphen d in detach mode hyphen hyphen name of the container is web, and hyphen is for port mapping on 8080 to 8080 on our local computer to or server to port 80 inside the container. Name of the image we use to create the container, that is static site 0.1. Okay, enter. So now docker ps container is running. Now when we run lazy docker, you will see here. So one container is running, and we have three images right now. Our networking is there, and we will also see the logs of the container when, how it is started and line by line what it runs. Also, if you go into the states, you will able to see like memory, CPU used by the container. So environment, if you click on env, it's not there. We are not using it right now. But if you see logs and this PID 15 and all the details about the current running container, whatever we have clicked here, a queue for coming out of that. So this is how we completed our second image, which is running like on localhost web server, which will show like welcome to the kingdom. Now let's push it to Git. I think I already pushed it, but let's see. Okay. Now we just added a new image, so we don't want to push everything what I have created, but I just want to push what we just created. So git add In images folder, we created 002 static side. If I git add dot, that means everything in that folder, but we just need to push this particular folder, and whatever we have learned, we put it in commit so that we will know. Git commit hyphen a, the like it's a second image, name of the image is for an nginx, like copy web root, that is like copy web root means index.html page where we copied it, hyphen p is for port mapping, hyphen d is for detach, and hyphen name, and then get push for pushing to our GitHub repo, remote repo. So it's up to date. So this is let's wrap up our this second image. Uh, so let us recap on our fingers, right? What we have learned. So we have learned to build on a real official base image, nginx, instead of starting from scratch. You learn the web root where nginx looks for files. You learn why this container stays alive, and inherited cmd running in the foreground, and the big four new flags. Example dash d for detached background mode, dash dash name to name your container, and dash p to map dash p to map a host port to a container port, plus the daily lifecycle commands like docker logs, docker stop, docker start, docker rm, dash hyphen app. This is image 2 of 100. Now interview movement, and this is a classic one. They might ask, what is the difference between expose and hyphen p command, dash p command, not hyphen p, dash p command. Here's the senior level answer. Expose in a Docker file is only documentation. It tells humans and tools which port the app intend to use, but it opens nothing by itself. The dash p flag is what actually publishes the port and connects your host to the container. Expose describes, dash p connects. Say that and you sound like you are shipped real systems. And now our homework. Change the page, rebuild and refresh the browser. Notice you must rebuild the image and rerun the container for change to show. Because the image is frozen, then make a different host port like I did, 8082 to 82, like that, and prove you can reach it there. And comment port with a crown when your page loads. In next video, image 3 will cow say oracle. We learn the run instruction and how to install software inside an image at build time. And you will watch how every run adds a new layer. Subscribe, join the kingdom, and remember, don't be the same, be better every time. Thank you.